Okay, so now the question is, what if you have something like this? Sine squared x dx. And it's even. In fact, there's no cosine. Well, there are some identities that you need to know from pre-calc. Sine squared x, you can actually use a half angle or a double angle identity to show that it's 1/2 1 minus cosine of 2x. Okay. Similarly, cosine squared x, you can use a half angle or double angle identity to show that it's 1 plus cosine of 2x. Okay. So these are important identities to know. Might want to write them down. And if I change the problem in light of those identities, this really becomes the integral of 1/2 1 minus cosine 2x dx. Pull out the half, integral of 1 minus cosine 2x dx. Okay, so this integral is very straightforward. There's the half hanging out. The integral of 1 should just be x. The integral of cosine is going to be sine of 2x, but because you'd have to do a u sub, it's going to be another 1/2 plus c. Okay, so whenever it's even, you're going to need these identities. So what if they're both even? Let's say, what if I have a cosine to the 4th of 2x, and then I have a sine squared of 2x. I can't isolate anything, because if I pull out a cosine, I'm going to be left with a cosine cubed, which is no good because I can't use the Pythagorean identity. So it turns out I have no choice. I just have to change this. Let me change this one first because it's a little bit easier. So this was 1/2 1 minus cosine, double the angle, right? So if you look at the identity, whatever's here, it's doubled there. So in this case, it should be cosine of 4x. Okay, this is a little bit more troubling. Again, that's going to be cosine squared squared. So you can change this into 1/2 parentheses 1 plus cosine 4x and integrate. Okay, so this will become algebraically messy because you're going to have to FOIL this out. You're going to have to distribute this. Just to see how that works, let's actually work out the entire problem. So I'm going to square the half, and then I'm going to have to FOIL the 1 plus cosine. Okay, so if I square the half, it's 1/4. If I FOIL the 1 plus 4 cosine, it's going to go 1 plus 2 cosine 4x plus cosine squared 4x. And then this one will just remain as a half, 1 minus cosine 4x dx. Okay, let me pull out the 1/4 and the 1/2, so that pulls out as an 8. And then I get this mess. 1 plus 2 cosine 4x plus cosine squared 4x times 1 minus cosine 4x. Okay, dx. Believe it or not, you're going to have to FOIL things out, and it's going to get a little bit messy. I'm going to have to take this. I'm going to first share the 1. So this is not the most exciting thing, but I'm going to distribute the 1 on through. So I'm going to have a 1/8 integral, and I'm going to distribute the 1. So I'm going to get a 1 plus 2 cosine 4x plus cosine squared 4x. And next I'm going to distribute the minus cosine 4x, and I'm going to share that with everything. So I'm going to get a minus cosine of 4x. Going to go into the second line, and then if I multiply these two, I get a minus 2 cosine squared of 4x plus, or minus, if I distribute it to the last term, cosine cubed of 4x. Okay, and this whole entire thing, dx. Okay, so I have a 1/8 integral. Let's collect like terms. The 1 doesn't really have a friend. The 2 cosine 4x can combine with this one, so that's going to become a plus cosine 4x. Okay, this one can combine with this jobby, so it's going to be a minus cosine squared 4x. And then there's the lone cosine cubed 4x dx. Okay, seems simple, but in order to integrate this, it's actually very complicated. To integrate this part is straightforward. to integrate this part, you got to think about it. So I'll perform it here without the 8. So how do you integrate the cosine squared of 4x? Well, believe it or not, you're going to have to use the identity one more time. 1/2, 1 plus cosine of double this, so 8x dx. Okay, and that you can integrate. To integrate this last part, okay, so how do you integrate the cosine cubed of 4x? You have to use the method from before, where you're going to actually isolate a cosine. And then use a trig identity here, 1 minus sine squared. Okay, and then do a u sub, where u will equal sine of 4x. So you can see it gets very, very messy. This is where it might be helpful to check your answer on Mathematica, just to verify.